we found a number of different pollen types that could help us identify a chronology. For example, we found Zea mays. And Zea mays, of course, comes from the New World and was introduced into Italy. And so the historical documents that we had found at this point indicate that Zea mays was introduced into our area about 1760 AD. So with our first occurrence of Zea mays, which is almost at 1 meter depth, we know that this is somewhere around 1760 AD. So that's a nice calendar age. There are some other interesting things. Cannabis production is very high in this part of the record. And when we look at the historical records of the use of cannabis in this area, between about 1600 and 1850 AD, there was a lot of cannabis production for rope for sailing ships. Okay? And so we have a good history that tells us that when we see this huge increase, we're somewhere between this time period. And then we had the increase in pine at the very top. Pine is not native in this particular basin. These are plantations that were put in by Mussolini, and we know that they were planted in the early 1900s. And so we know that the beginning of this represents about 1920 to 1940. So using these historically documented cultivated types, we know that when we're in this upper portion here, we have to be at least in this period that represents probably the last 3 centuries, okay? So if you replot these, they make actually a pretty good, consistent line for sedimentation rates. And if we assume that the surface is modern and not 1,000 years old, which is a good assumption, and we place each of these in order, we get a very good representation of the modern period. And so we use those data to specify that this upper section represents the modern period, at least the 17th to the 21st century. That we're comfortable with. Okay. Then, we have a lot more radiocarbon ages. Okay? We took radiocarbon ages on sediment all through the core. And what you'll note is that though we're fairly confident that our sedimentation rate looks like this, then suddenly everything gets much, much older. We think that this is because of different levels of contamination in the sediments from the carbonate coming out of the sediments. We think that all of these are far too old. We think that they're an indication of some levels of erosion, of very old material, and possibly different changes in erosion in time. We don't know entirely how to solve. We don't know entirely what they mean yet, other than we don't think they're reliable for our chronology, because our chronology is looking pretty good here, and this is not so good. So we don't use those radiocarbon ages to build the chronology. We know that by the time we're here, we're somewhere around between in the 17th century. Well, just prior to the 17th century, we see, or just prior to this zone, we see a very large increase in alder. Now, alder pollen and alders themselves require standing water to grow. So when you see alder, it's an indication of a very high water table or flooding. Note that in the modern period, when we saw no trees like that, there is none of this pollen. So there's some very significant environmental change associated with this that we think is associated with an increase in rainfall and an increase in water table, and potentially a change in how the basin is being managed.